Hello, wonderful students, and welcome to another video. This is Notes 4.1.3, Factoring More Quadratics. We have two learning goals. Did I say two? Because I meant one. Okay, here we go. Your goal is that you will be able to, I'm going to write this in the first person. 1, factor quadratic expressions even if one of the terms is missing. Or if I am given a quadratic not in standard form. Period. Okay, so for the first problem, we're going to practice our method from last class. This says without tiles, but we didn't use tiles, so that's fine. Factor each quadratic expression below if possible. We're going to use a diamond problem and area model for each one. So for the first problem, I have x squared plus 6x plus 9. Well, I know that my x squared term goes in the upper left with my area model, and I know that my constant 9 goes in the bottom right. I know that the diagonals of my area model each multiply to the same thing. So since I know that these two multiply to 9x squared, I know that these two will also multiply to 9x squared. I also know what these two add to. So these two are going to add to my middle term, which is 6x, which is what I put in my diamond problem because I know I need two boxes that will multiply to 9x squared and add to 6x. Well, that's going to be 3x and 3x. And if you didn't know that, you could grab your multiplication chart and check out all the factors of 9. I'll grab that right now. The factors of 9, as you see, are 1 and 9 and 3 and 3. 1 and 9 wouldn't work because 1 plus 9 is not 6, it's 10. I needed 3 and 3. Okay, now I take these two pieces of my diamond and I put them in the missing boxes of my area model, 3x, 3x. Then I find the outside of my area model. See, the greatest common factor of x squared and 3x is x. Once I have this, I can find the rest. X times x is x squared, x times 3x, x times 3 is 3x, and the same down here. My answer is x squared plus 6x plus 9 equals x plus 3 times x plus 3. And actually, I can write this even more compactly because x plus 3 times x plus 3 is x plus 3 times itself, which I can write as x plus 3 squared. So this becomes x squared plus 6x plus 9. I would take either answer, but I like this one the most. Okay. Next problem. 2x squared plus 5x plus 3. Well, I know my x squared term goes in the upper left. And my constant term goes in the bottom right. Now I need to figure out what these diagonals are going to multiply to. Well, 2 times 3 is 6. So this will be 6 and x squared. And I need these diagonals to add to my middle term, which is 5x. 5x. Okay. What multiplies to 6 and adds to 5? Well, I could look at my factor chart. I'll write them. Factors of 6. That's 6 times 1, or 2 times 3. And 2 times 3. 2 plus 3 is 5, so that's what I want. 2x and 3x. Okay, I take these and I put them into the missing boxes of my area model. 2x here, 3x here, and I continue to factor. Okay. The greatest common factor of 2x squared and 2x is 2x. Up here, I'll do 2x times what is 2x squared? Well, that's x. 2x times 1 is 2x. X times 3 is 3x. So I can get my answer, which is 2x squared plus 5x plus 3 equals 2x plus 3 times x plus 1. I've written my area as a sum, the pieces added together, and a product. Length times width. Next problem. X squared plus 5x minus 7. Okay, I know my x squared term goes here. My constant term goes here. X squared times negative 7 is negative 7x squared. So I know these two boxes need to multiply to negative 7x squared, and I know they need to add to 5x. Okay, I'm going to write down my factors of 7. Negative 7. Now I know that the larger of my two factors will be positive because I'm trying to add to a positive number. So that'll be negative 1 times 7. Wait a second, that's the only factors of negative 7. Okay, let's check. Does that add to 5? No. Well, this is not factorable. Since there are no factor pairs for negative 7, which add to positive 5, period. So this one is not factorable. And you can use the script. Anytime you're telling me that something doesn't factor, you had better tell me that the B term won't work with the terms A times C, which this sentence does. Nope. Okay, next problem. 3m squared plus m minus 14. Okay, I take my m squared term. It's okay that it's an m, and I put it in the upper left of my rectangle. I take my constant, and I put it in the bottom right. Now, I multiply the two together. 3 times negative 14 is negative 42. So I want something that multiplies to negative 42, m squared, and adds to positive m. Let's check my factors of negative 42. Now I know I want to add to a positive number, so the bigger factor will be the positive one. Okay, let's see. 21 and negative 2. That doesn't make positive 1. Let's see. 7 and negative 6. Well, that works. 7 plus negative 6 is positive 1. So I have 7m and negative 6m. 7m and negative 6m. Okay, greatest common factor time. The greatest common factor of 7 and 3 is 1. So this will be 1m squared. If you just wrote m, sorry, just m, not m squared. If you just wrote m with no 1 in front of it, that's excellent. You don't need that 1 there. Okay, up here, 1m times 3m is 3m squared. Over here, 1m times 7 is 7m. Down here, 3m times negative 2 is negative 6m. Final answer, 3m squared plus m minus 14 equals 3m plus 7 times 1m minus 2. Yay! Next page. Now the next page, wonderful students, is where we get into new stuff. Okay, number 425. We've been working with quadratic expressions written in the form ax squared plus bx plus c. That's standard form. But what if a term is missing? Or what if the terms are in a different order? Consider these questions while we factor the expressions below. 9x squared minus 4. Well, let's just start. Okay, I know my x squared term goes in the upper left. And -4 is my constant because there's no variable attached to it. What should I do for b? I don't even see a b. Oh, I get it. Haha. 9x, this is the same as 9x squared plus 0x minus 4. When there's no x, you can write it as 0x. Isn't that fun? Okay, but wait, hold on. Does that mean, let's do our diamond. 9 times 4 is -36x squared here. And I'm trying to add to 0? Well, let's just list our factors of -36. Oh yeah, that's gonna work. 6x and -6x. Woo! Because 6x minus 6x is 0. And they multiply to -36x squared. I am pleased. Okay, let's get our greatest common factor going. Greatest common factor of 9 and 6 is 3. Greatest common factor of x squared and x is x. Now I can do the rest. This is gonna have to be 3x. 3x times 2 is 6x. This has to be -2. 3x times -2 is 6x. Final answer. 9x squared minus 4 equals 3x plus 2 times 3x minus 2. Box it. We're done. Huh, that wasn't so bad. Okay, let's see about this one. I'm just thinking, everybody. Okay, let's go. Start with our little boxy box. Our 12x squared term goes here. Now 16x is not my constant, so I better not write it here. In fact, the constant is missing. I could write this as +0, and then my constant is 0. But then, wait a second, when I do my diamond, I have 0 on top, because 12x squared times 0 is 0. This is weird. Well, I don't mind. I need to add to -16x and multiply to 0. There's only one way to do that. And I can only do that if one of my factors is 0. So I'm going to throw 0x right here and -16x here, and we're going to see how this works out. Okay, I need my greatest common factor, which is 4x. 4x times 3x is 12x squared. 4x times -4 is -16x. And down here, look, you can write a 0, that's fine, but you really don't have to. So you can write your answer as 12x squared minus 16x equals 4x times 3x minus 4. If you really want to follow the format, you could also have written that as 4x plus 0 times 3x minus 4. But that 0 is not necessary, and I'm not going to include it in my version of the answer. This 0. Okay, ready? Next problem. Make a box. Okay, I know my k squared term goes in the upper left. And I know my constant term, that's the term with no k, goes in the bottom right. I'm gonna make my diamond. And I know I want my 2 missing boxes to multiply to this same, it's the same product as these boxes. So 8 times 3 is 24. That's gonna be 24 k squared. And on the bottom, what do I need to add to? Okay, so this is where students get confused. I always say add to the middle term, but really what we're adding to is the term with the variable raised to the first power. So it's going to be negative 10k. I strongly suggest that when you see a problem and the terms are not written in standard form order, that you write it in standard form, just to make it so you don't have to do so much mental, so you don't have to have as many mental processes going on at once. If I rewrite this in standard form, meaning with my exponents going from biggest to smallest, I have 8k squared minus 10k plus 3. All right. And now it's easier to see what the middle term is, negative 10k. Okay, I need two things that multiply to 24 and add to negative 10. Okay, you can go through your chart. I'm just going to write down right now that it's negative 6 and negative 4, negative 6k and negative 4k. I knew they both had to be negative because I'm trying to add to a negative number, and a negative times a negative is a positive. Okay, I'll put these in, negative 6k, negative 4k. Greatest common factor. The greatest common factor of 8 and negative 6 is positive 2. And this becomes positive 2k. 2 times 4 is 8k squared. 2 times 4k is 8k squared. 2k times negative 3 is negative 6k. And 4k times positive 1 is negative 4k. And then I can write my final answer. Please write your final answers in standard form. So we should have 8k squared minus 10k plus 3 equals 4k minus 3 times 2k minus plus 1. Next problem. Okay, look everybody, this is not a quadratic. There is no x squared term. So this is not quadratic. But you can still factor it. It's just not going to be, there's not as much to it as there have been to our previous problems. Throw this in standard form and then factor it. In standard form, I'd have negative 100m plus 40. And I factor out the greatest common factor. So the greatest common factor of negative 100m and 40 is 20, making my final answer 20 times whatever it takes to get to these. So 20 times what is negative 100m? Well, it's negative 5m. 20 times what is 40? Well, that's 2. So negative 5m plus 2. Box it. You're done. Woohoo! Okay. We've done a few problems. They were a little bit unusual. Now we're going to say what we're trying to get from them. How can I handle it when things get weird? For example, what if the B term is missing, like it was in part A? Hey, no big deal. It just means that B is 0. Write in 0 as B and proceed as you normally would. Pretty cool. Okay. There's more to the story. You don't have to know this yet, but it also means that you can write this as the square root of ax squared plus the square root of c, positive c, multiplied by the square root of ax squared minus the square root of positive c. It's actually special when b is missing. But for now, it's enough to just say, make b 0. Okay, well, what if the c term is missing? As it was in part B. No big deal. It just means that c is 0. And then I say it's no big deal, and it's true. You can just make c 0 and proceed as normal. But if you look, it actually is kind of special because it makes the problem easier. Really, all you needed to do was find the greatest common factor and factor that out. We didn't need the whole process. We could have just done that top row. Next, what if the terms are out of order? That's what it was like in part C. Hey, no big deal. Just put them in order. What really matters, everybody, is which term belongs to x squared, which term belongs to x, and which term is your constant. You can put them in the usual order based on that. Okay, last but not least, what if the x squared term is missing? Well, look, x squared is really important. If there's no x squared, then it's kind of a big deal. It's a big deal. Without x squared, you don't have a quadratic. The x squared term is what makes your trinomial a quadratic, or your binomial, or anything. If their biggest power is x squared, you've got a quadratic. Later on in unit 5, we'll start graphing quadratics, and we'll see that the x squared term produces graphs that look like this or this. If you don't have that x squared term, you would just have a line. No x squared. Yes, x squared. And then if you had even bigger powers, you get even more different graphs. Like, you don't have to know this yet, but this would be an x cubed. They're pretty. Anyway, we continue. All right. This problem previews our next lesson. 4.1.4 for now. We're going to do it. Almost our entire lesson from 4.1.4 is contained within problem 4-26. So it's a nice problem. Okay. 4x squared minus 10x minus 6. Let's use a diamond and an area model. Okay. Okay, 4x squared, negative 6. The top of my diamond has negative 24. X squared, bottom has negative 6. The two numbers that will work for this are negative 12x and 2x, because those multiply to negative 24x squared and add to negative 10. Sorry, I should have been negative 10 right here, everybody. My mistake. Okay, I throw these in here. Negative 12x and 2x. Greatest common factor. 4x goes here. Just x up there. 2 here. And negative 3 here. And you might say, well, what's the problem, Miss McClellan? Like, this isn't special. We've done this 1,000 times. And sure, we can write the answer right away. 4x squared minus 10x minus 6 equals 4x plus 2 times x minus 3. But listen, something is happening. This is not the only way to write the answer. For all the problems we've done before, we've had unique answers. For this one, that's not the case. So let's look. What if I had written 2x right here? Those boxes should be interchangeable. 4x squared, 2x, negative 12x. And then I found my greatest common factor, which is now 2x. Okay, well, 2 times 2 is 4, 2x here, negative 6, and x. Well, I also have that my original problem equals 2x plus x times 2x minus 6. So the question becomes, what's the right answer? And if we're just talking about equality, both of these are correct because both of them are equal. But we do have a format that we like to write things in, and that has to do with something called factoring completely, which will be the topic of our next lesson. For now, it's enough to realize that sometimes something happens here and it's weird. There's more than one answer in this situation. So there's more than one possible correct answer. And we know because we found it, but I'm going to write something other than I know because this happened because all of the terms in my original trinomial have a common factor. What we'll learn next class is that this could really be written as equal to 2x plus 1 times x minus 3. And that would be the most common way to see this problem written as a final answer. You want to have all the parts as distinct as they can be, meaning you don't want to have any common factors in your terms. Okay, ready? Next problem. Challenge. Class. I strongly encourage you to turn off your video and try this problem on your own. That said, I'm gonna solve it now. Okay. So Emily Ray designed an area model puzzle for her team to solve. What are the missing portions of the area model? So for this one, we have to figure out what goes here, 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 and here. Okay. I'm going to do this first. So I'm going to solve for this box first by multiplying x plus 7 and x minus 2. So box 2. Okay. I'm doing this one first because it looks the easiest to me because multiplication is easier than factoring. And this is the only one that doesn't require any factoring. Oops. Okay. Okay, I multiply those together. And I get x squared plus 5x minus 14. Oh boy, how fun. How am I going to figure the rest out? Okay. I'm going to do this part second. So this is a factoring problem. Here I go. Part 4. Trying to factor 3x squared minus 5x minus 2. I know my 3x squared terms goes in the upper left. Negative 2 goes in the bottom right. Diamond. I know I have negative 5x on the bottom of my diamond and negative 6x squared on the top because I multiplied those two. Okay. What two numbers? What two numbers? Well, guess what? I have a hint. I know that this needs to be x minus 2 because I know what the top part's going to be. Isn't that fun? Isn't that fun? Okay. 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 You know what? I don't even have to use the diamond. Isn't that fun? Negative 2 times 1 is negative 2. I can fill out the rest just from here. Gotta have 3x up there. Gotta have x here. Gotta have negative 6x here. Golden. This part must be 3x plus 1. All right. Let's go. Let's do part 1. Part 1. Okay. I know I'm trying to multiply 2 6x squared plus 1. And I know that the left-hand side of my box will be 3x plus 1. Okay, 1 times 1 is 1. 3x times 2x is 6x squared. 3x times 1 is 3x. 2x times 1 is 2x. I got it. Bang. 2x plus 1. Okay, now I'm going to do part 3, box 3. With multiplication. I just have to multiply x plus 7 by 2x plus 1. This is 2x squared. This is x. This is 14x. And this is 7. So I combine like terms. I get 2x squared plus 15x plus 7. I think we did it, everybody. Do I agree with my answer? I think so. Cool. Golden. Part B. Write an equation that shows the area of the entire rectangle as a product equal to its sum. Gross. All right. So product is length times width. I'm going to fold this up a little. Okay. Product is length times width. But my length and my width have like terms in them. So this is x plus 7 plus 3x plus 1 times x minus 2 plus 2x plus 1. I'm going to do the product first. So combining like terms, this is 4x plus 8 multiplied by, this is 3x minus 1. Just combined like terms. And then let's see this big mess in here. I'm adding everything together and I'm combining like terms. So let's see how many x squareds I've got. X squared plus 3x squared is 4x squared plus 2x squared is 6x squared plus 6x squared is 12x squared. Did I do that right? 4, 5, 6, 12. Good. 12x squared. Okay, let's check these. So this is positive 5x minus 5x, that's 0. And this is 15x plus 5x, that's 20x. Okay, let's do my constants. This is negative 14 plus negative 2, which is negative 16. Plus 7, which is negative 9. Plus 1, which is negative 8, minus 8. Okay, so final answer. 12x squared plus 20x minus 8 equals 4x plus 8 times 3x minus 1. I would accept this, but I would like it more if you factor out anything that has common factors in its terms. So each of these is divisible by 2, so I'd actually prefer you to write 2 times 2x plus 4 times 3x minus 1 is 12x squared plus 20x minus 8. Final answer. We did it. Yay! A wonderful class, a beautiful group. Have a good day. And make sure you turn in your notes.